All right, so we looked at direct variation the other day. So now we're looking the opposite way and looking at inverse variation. So right off the bat, it says find the constant of variation. Remember, that's k. And for direct variation, our equation, if you remember, was y equals kx. And how did we solve for that k again? That's right, we divided the y divided by the x. So let's see if I can do that here. Well, first of all, let's kind of take a look. As my x increases, as I go from 4.5 to 7 to 8 and so on, what's happening to my y? I'm starting at 8. Oh, I'm going down. So as x is increasing, my y is decreasing. So these are opposite. So I don't know if that doesn't seem like they vary directly anymore. So let's just attempt to do direct variation. So let's see if I can do y divided by x and see if they match up. So I'm going to grab this first guy, y divided by x, 4.5 divided by 8. And then I'm going to grab one more. Maybe I'll grab the one next below it, 1.44 divided by 25. Oh man, I should already be able to tell that this is not going to match up. Well, what would I get for each of these? 0.56 and 0.06. So should have warned you, don't write any of this down because this is all incorrect. So these are not matching up. They don't match up, so this is not direct variation, so I cannot divide y divided by x. So take a look. Since it's not direct variation, we should notice that because as x increased, y decreased. So this is going to be inverse variation, and we'll talk in just a sec on what we can do instead. So inverse variation are going to come a little bit different. So instead of y equals kx, it's going to be y equals k divided by x. So instead of being multiplied, they're divided. So it's kind of the opposite. And same thing to solve for k. It's just the opposite. Instead of taking y divided by x, we are multiplying the two, y times x, to find the k, the constant of variation. So y and x are inversely proportional, right? If k, and k is the constant of variation. So this is the case is like, so I guess one situation I could think for like my own life, I guess the more time I spend at work or doing work means the less time I have for free time. Like those are inversely proportional. Okay, and we'll look at how we can set those up as a proportion as well eventually. So how do I find that constant of variation? And write an equation. So the equation now is what? Y equals k divided by x, not k times x, k divided by x. And to solve for the k, what do? Yeah, we multiply the two now. We take y times x. So all I got to do is times them, times them, times them. You just times them whenever they're inverse. And to check to see if they're inversely proportional, what do? You check to see if one increases as the other decreases, right? They should be opposite. So as my x gets bigger, my y's are what? Decreasing. So perfect. So I should be able to just multiply. So to find k, I could take that first one, 4.5 times 8, and I get 36. So very good. And if I do that for any of them, I could try another one. If I tried k equals, let's try this one, 3.6 times 10. 3.6 times 10, what do I get? There you go, 36. I should always check a few. And then to write my equation, remember we plugged that guy in for k. So I'd say y equals 36 over x for inverse variation. So now they're just being divided instead of multiplied, but the k is always on top. So this is similar to the day before, except now we have inverse proportional. So it says they're inversely proportional when x equals 4.5, y equals 7. It says write the inverse variation equation. So I want to write my y equals k over x. So that means I got to solve for k first. And how do we do that? That's right, we just multiply the two. And so that gives us 31.5, and then I plug that guy in to my equation. So I say y equals 31.5 over x. There's my equation. Find x when y is 6. So y is, let's rewrite my equation here, 31.5. So y is 6, and I want to find what x is. Well, this is tricky. How would I solve for that? We haven't learned how to do this algebraically, but we do know how to handle proportions, right? So it looks like I have a fraction here. Can I get a fraction over here for my 6? Yeah, I could put it over 1. So now I could either take the cross product Or what's our other method? I could flip-flop them, right? I could put 1 over 6 equals x over 31.5, and then multiply both sides by 31.5. So a couple different ways to do that. And you could solve it however you like. I think most of you are getting used to your cross product, so I'll take 6 times x, and then 1 times 31.5. And what do we do with those guys? Right? We set them equal, and then we divide by 6. So x would equal 5.25. There we go. So you just kind of have to think through it. Think about what you know in order to solve those guys. So what if you're given tables and you need to decide if it's inverse, direct, or neither? And then if it is direct or inverse, you have to write the equation. Well, the first thing you should do is see whether they increase or decrease on the x's and the y's. Okay, that's the first thing you should check for. So look at my left guy. As x is increasing, as it goes from 2 to 4 to 5, what's happening? My y's are also increasing, right? So that's good. So I'm thinking it's direct variation, so I'm going to write y equals kx. So how do I solve for k? Well, we divide, right? Y divided by x for direct variation. So now I'm going to test it. So I'll go 16 divided by 4. I should do a few of these guys. So that equals 4. That's good. I go here. I go k equals 48 divided by 12. That's good. That's 4. Looks like it's going to be good. Hold up. 21 divided by 5. That does not equal, that's like 4.2. So is that direct variation? No. This guy ruins it right here. Okay, so you need to check all of them just to be safe. So this is neither. So just be careful as you check those out. How about this one? Okay, as x increases, so as x increases, what's happening to y? It's going from decreased, decreased, okay, this one's decreasing. So I'm thinking inverse. Well, I better double check. So now what is my equation? Y equals k divided by x. And to solve for k, we have to multiply the x and the y. So multiply, multiply, multiply. And I better just check them all. And if I multiply all these guys, I end up getting 21.5. And I should do that to all of them. But I do. I get 21.5. So then it says list. So this is inverse variation. And if it is, write the equation. So if it's inverse, I should say y equals, well, the k. So 21.5 divided by the x. There's my equation. Okay, so always look to see if they're increasing or decreasing. And then that can tell you whether it could possibly be direct or inverse. All right, let's use this in real life here. So it says Karen weighs 104 pounds and is sitting 3 feet from the center. So I'm going to draw that over here. So Karen is sitting, let's say that's about 3 feet right there. And she's 104 pounds. All right, and she's playing with her sister who weighs 75 pounds. How far should her sister sit in order to balance the teeter-totter? So if she's 75 pounds, and let's say this is about 3 feet right here, do you think she should sit closer than 3 feet or further away to balance it? Yeah, I would think further away, right? So she's going to be further away. So there's 2 ways to do this now. One way is I could set up a proportion. Let's look at that. So this is goofy. So before you set up a proportion, you should always decide whether it's direct or inverse, okay? Because direct, if it's direct, you want to be consistent. You want to set up your proportions normally. That means you want to be consistent. So like if you have inches on top on one fraction, you should have inches on top on the other fraction. Okay, well in this case, let's see, is this direct or inverse? So let's think. If Karen's 104 pounds and she's 3 feet away and we decrease weight, so we're decreasing in weight, what are we doing in distance? Looks like we are increasing in distance, right? So this is inverse. So this is kind of scary. So if it's inverse, yeah, we multiply them for inverse, don't we? So we take that y times the x. So really, if I go 104 times 3 for Karen, I could do the same thing for her sister and say 75 times x, which I don't know. So 3 times 104 is 312 equals 75x. And to solve for x, we should divide by 75. So x would equal 4.16 feet in order to balance that teeter-totter. And don't forget that label, right? Labels are important. Okay, so story problems get tricky depending on whether it's inverse variation or direct variation.